welcome. So we're going to be analyzing position, velocity, acceleration. We're going to do one with an equation and one with a graph. All right, so the position, x-coordinate of a particle moving on the x-axis, is by x of t equals t cubed minus 4t squared plus 3 for t greater than or equal to 0. We want to find the displacement of the particle during the first 2 seconds. So to do that, we need to find the position at t equals 0 seconds and t equals 2 seconds, right? And find the difference. And displacement is the total distance traveled. Let me write that in. So displacement equals total distance traveled it's always positive. Right? So it's always going to be a positive value. That looks like O waste. How about always? Oops. Always greater than 0. There we go. All right, so look at this. I guess I can use the same color. Hopefully it's not too crowded here. Actually, we'll put it up here. So x of 0, of course, it's just going to be 3. Right? That was pretty easy to figure out. And then the x of 2 is going to be 2 cubed minus 4 times 2 squared plus 3. So that's going to be 8 minus, so that would be 16. So negative 8 plus 3 is a negative 5. All right, so we want to find the total distance traveled. So it started off at 3 and traveled to negative 5. So remember that displacement is always positive. So the displacement equals the absolute value of the difference between where it started, 3, and where it arrived, which is negative 5. So it traveled 8 units. Doesn't tell us it tells us the first tells us the units for time. Doesn't tell us the units for position. How about we use in centimeters? So let's make it 8 centimeters it traveled. And that makes sense, right? Because it would have to go 3 centimeters to get to the x-axis, and then it traveled another 5. Find the average velocity of the particle during the first 2 seconds. So first of all, we need to find velocity, the equation for velocity. So that's going to be v of t. Remember, is the derivative of the position equation. So that's going to be, it's going to be a derivative of t cubed minus 4t squared plus 3 will be 3t squared minus 8t. I have this annoying little chain blocking. Yeah, okay, so make sure I saw the equation correctly. So minus, 8t. All right, so v of 0 is just 0, right? So how about v of 2? So that's going to be 3 times 2 squared minus 8 times 2. All right, that'll be 12 minus 16. That's negative 4. So to find the average velocity, right, we're just going to find this. It's just the slope of the secant line, right? But this time it's the secant line for velocity, right? So the average velocity is just the slope formula, right? So that's going to be negative 4 minus 0. Actually, let me write the equation just to make sure it's all clear. So average velocity in this case is going to be v of 2 minus v of 0 divided by 2 minus 0. We should really do that. And by the way, if you're taking a test, especially the AP test, I would write that out because it shows you know what you're doing. And then if you made a slight calculation error, at least you've represented velocity correctly, the average velocity correctly. All right, so v of 2 was -4, and you'd get points for that. Minus 0 divided by 2 minus 0. So that's going to be -2. And we should have units on that, which is why I put units there, centimeters per second. All right, so that's its average velocity, not the instantaneous velocity, right? Instantaneous velocity we'd be plugging in for a moment of time. But this is the average velocity from 0 to 2 seconds, was -2 centimeters per second. Find the instantaneous velocity of the particle when t equals 4. All right, so now we're going to use our derivative and evaluate when t is 4. Right, so v of 4, because instantaneous velocity, right, we use the derivative, right, and we evaluate the derivative. For our average, right, we're finding the slope of a line connecting them, 2 points in time. So the moment the time is 4 seconds, the instantaneous velocity is 3 times 4 squared minus 8 times 4. Right, so v of 4 would be, so that's going to be 48 minus 32. So that is 16, right? 48, 32, yeah. Sometimes keeping the numbers in my head. I'm a very visual person. So that is 16 centimeters per second. Right? That's the moment we get to 4 seconds, that is the particle's velocity. Find the acceleration of the particle when t equals 4. Of course, first thing we're going to have to do is find the equation for acceleration. Right? So we have a of t, which is the derivative of velocity, which is the second derivative of position, is going to be, looking for the, here there's the velocity equation. So derivative of 3t squared minus 8t is going to be 6t minus 8. So a of 4 is 6 times 4 minus 8. So 24 minus 8 is 16 centimeters per second squared. Right? So at 4 seconds, right, notice that, let's actually add a little bit to it. Didn't ask us, but let's answer it anyway. Right? And so we're going to describe the motion of the particle, but let's just explain this part here. So notice that velocity is positive and acceleration is positive at t equals 4 seconds. So at t equals 4 seconds, the particle is speeding up. How do we know? Both velocity and acceleration are greater than 0 at t equals 4. And there we go. All right? So we know at least at t equals 4 seconds, our particle is speeding up. If you're asked to describe the motion of the particle, right, that means to explain it from the beginning onward, right, to the end. Well, this may not end, but to be able to find your critical points for both the velocity curve, for the acceleration curve, and be able to explain whether the object is speeding up or slowing down, right, between every one of those critical points. So let's do that. And to do that, we need to create a sign chart. Right? And to even create the sign chart, you know what, let me, I've written in every color. So let's go back to blue. I like to kind of keep the colors separated. Let's create a sign chart. So to do that, we need to find our critical points. Right? So our critical points or where either velocity is 0 or acceleration is 0. So now let's set velocity equal to 0. So we have 0 equals 3t squared minus 8t. So we'll factor out the t, and we've got 3t minus 8. So our critical points here are t equals 0 and t equals 8/3. Right? So essentially 1 critical point, because 0 is when it starts, right? Because there's no such thing as negative time. So now let's find, so 0 is an endpoint, right? But t equals 8/3 is going to be one of our important critical points here. And then let's set acceleration equal to 0. So we have 0 equals, I'm just looking for the equation for acceleration. There it is, 16 minus 8. So 0 equals 16 minus 8. So 8 equals 6t. And if we divide both sides by 6, 4/3 equals t. So those are our critical points, the ones that are really going to matter here because this is dealing with time, which has to be positive, and we haven't gone anywhere at t equals 0, is going to be those two values, the 8/3 and the 4/3. Okay? So we have what happens at 4/3 and what happens at 8/3. Right? Now, 8/3, of course, is greater than 4/3. So we can create one chart here that has the important points for. Actually, we're going to create one chart, but let's first evaluate velocity, and then we'll evaluate acceleration. So here's v of t, here's a of t. All right, so this is our critical point. For our critical point, right, we get 0. Right? If we were to plug in 4/3 into 3t squared minus, well, it helps not to reverse them. If we were to plug in 8/3 into 3t squared minus 8t, we would get 0, right? So that's where we have a critical point. We want to find out, so at 8/3, that's where we can change, right? That's where we can change directions, right? Because you have to stop to change directions, right? So that means the velocity can go from positive to negative or negative to positive only at 8/3. Let's find out what it's doing on either side, right? So we want to choose a value that's positive, right? But less than 8/3. So how about 1? 1's a nice one, right? Because from 0 to 8/3, it's not doing anything different, right? Because it can only change at 8/3. And then we need a value greater than 8/3. All right, so let's take 3. That's greater than 8/3. All right, so if I plug in 1 into the derivative, I'd have 3 minus 8. Well, that's a negative number. Right? So we're moving in a negative direction from 0 to 8/3. If I plug in if I plug in 3, right, or anything greater than 8/3, let's see what happens. So that would be, 3 squared, that'd be 27 minus 24. This is a positive value. All right, so notice that we're moving in a positive direction, right, from 0 to 8/3, a negative direction from 0 to 8/3, and then we turn around and move in a positive direction from 8/3 onward. Right? Let's now evaluate the acceleration. Right, so our critical point here is 4/3. That's a 0. So we need to plug in something on either side of that critical point. You know, we could use 1 again. That's less than 4/3. And why not? Let's just use 3 again. Sometimes you have to have, if you've got more than one critical point, sometimes you have points in between the two different critical points. But here, we've only got one critical point for each one of them. And 1 is less than 4/3 and 8/3, and 3 is more than 4/3 and 8/3. So that will work. If I plug in 1 into the equation for acceleration, we would have 6 minus 8. That's going to be negative. If I plug in 3 into the equation for acceleration, I would have 18 minus 8. That's going to be positive. So look at that. We are always speeding up, aren't we? except, of course, at our critical points, right? Because there we are at 0, right? That's kind of interesting. No slowing downs on this one, just speeding ups. Let me just make sure. Yeah. Yep. Just speeding ups. All right, so let's now describe the motion of the particle. All right, so and I'll write here in green. The particle moves left from 0 to 8/3 and right from and we don't know when it stops, right? So right for t greater than 8/3. Right? We don't have a stopping point here. We weren't told that it stopped at some point in time. We're just told that t is greater than or equal to 0. Right? The particle is speeding up. Oh, you know what? Oh, bad me. What did we forget to do? We forgot to justify. It's probably because I'm running out of space here, but never fear. Let's justify. And let's also get just a tad more space. All right, so the particle, and you know what? Instead of cramming it in there, because now it's under critical points, and it's not a critical point, it's our description. Let's put it over here. So the particle moves left from 0 to 8/3. And we know that because v of t is less than 0. The particle moves right for t greater than 8/3 because v of t is greater than 0. The particle is speeding up from 0 to 4/3, 4/3 to 8/3, and t greater than 8/3. Because v of t and a of t have the same sign on these intervals. Notice I broke it up at the critical points, because at the critical points either the velocity or the acceleration is 0, right? And so that is not the same sign. That is not 0 is not positive, 0 is not negative, right? If our velocity is 0, right, because we're turning around, it's kind of hard to say that we're speeding up, right? But right after we turned around and our velocity was 0, we just kept speeding up, all right? So make sure you don't write it's speeding up everywhere, right? Because then you're saying it's speeding up when the velocity is 0. How does that work? Right? So make sure you take the critical points out of it, and then you've got this one answered correctly. All right. Now, if you have any questions, let me know. But here's a little analysis using a sign chart of the movement of the particle. The sign chart is going to be very helpful. Just try and be very neat on your sign charts so that you don't get confused. Here I color-coded so we can see our critical points were 8/3 and 4/3, and I put a 0 over that as well so we can see that those are our critical points. And then we're just evaluating on either side of those. So this was actually a pretty easy sign chart to evaluate because we only had one critical point for each one of them. So now let's take a look at a graph, and we're going to analyze the graph. Always make sure you know what your graph is of, right? That's the key, that's the first most important thing. All right, it shows velocity. right? So don't think that it's position. Don't think we're moving left from 0 to 2, right? That wouldn't be true, right? Because that's not position, that's velocity, right? We're moving right, actually, from 0 to 1, anyhow, because we're above the x-axis. So now we want to determine when the particle moves right, when it moves left, when it speeds up, when it slows down, right? So let's answer the moving right and moving left part first. Then let's answer the acceleration, positive, negative, 0, and then let's come back to the slowing up and speeding down, speeding up and slowing down, because that's a lot easier to answer after we've answered the acceleration, right? Because acceleration, we need velocity and acceleration to determine speeding up and slowing down. All right, so when does the particle move right? So and we'll justify all of our answers. So the particle moves right, and this all should be in your notes, so notice here we're moving right, and here we're moving right. All those places were above the x-axis. So from 0 to 1, and from 5 to 7, and that's because, this is a symbol for because v of t is greater than 0, right? It's above the x-axis. All right, so now let's figure out where our particle is moving left. Well, everywhere else it's moving left. All those places it was below the x-axis. So particle moves left from 1 to 5. And we know that because the velocity is less than 0, right? So here, particle moves right. Down here, particle moves left. So it's pretty easy to analyze position from velocity. So we'll come back to the speeding up and the slowing down. We won't forget, we'll underline it. Speeding up, slowing down. All right, when is the particle's acceleration positive, negative, and 0? All right, so now to figure that out, I'm going to just erase this part here. Let's look at the slope of velocity. So right here, the velocity has a positive slope. Actually, let me not write in blue, right next to. It makes it seem like the particle is moving left on that line. Let me just clarify this. I'd hate for you to later look at this and say, what? It's not moving left on that blue line there. Oops. But apparently I wanted to answer the other half first. So particle moves right because we're above the x-axis. Particle moves left below the x-axis. And actually we should, I should even specify that more. So it's v of t that's below the x-axis here. I'll make this nice. I don't like it when my notes aren't clear. And particle moves right, v of t above x-axis. Right. So now let's look carefully at our slope of our velocity equation. So notice right here, velocity has a positive slope, right? So A of t is going to be positive when v of t has a positive slope. All right, so our when is the particle's acceleration positive? So the particle, actually I have to put acceleration. Acceleration is positive and that is from 2 to 6. And we know that because v of t has a positive slope. Now the rest of the time, right, so a of t is going to be negative when v of t has a negative slope. Just like when the position had a negative slope, velocity is negative because we're moving to the left. And when the position had a positive slope, velocity was positive because we're moving to the right. Right? So acceleration is negative from 0 to 2, and then again from 6 to 7. And we know that to be the case because v of t has a negative slope. And so it's not too hard to figure those things out. And zero slope is where we have a critical point. Now we don't have usually it's a horizontal tangent. We don't have a horizontal tangent because we don't have that. We have these abrupt changes, right? We have corners. So right here, the derivative for velocity would be undefined. And the same thing here. The derivative for velocity is undefined right at those corner points, right? Because you can't take the derivative of a corner. All right, so acceleration equals 0 when v prime of t, there we go, when v prime of t equals 0 or undefined. So a of t, I could put a of t. A of t equals 0 at t. Let's put it over here. At t equals, my t and my v are running together. There we go. So that was 2 and 5. No, excuse me, 6. At t equals 2 and t equals 6 seconds. I'm assuming it's seconds. All right, let's go back now to speeding up and slowing down. All right, so we can make a little chart. And we'll put that little sign chart up here. Especially if I move this down, I'll have a little bit of space. All right, so now v of t has 2 critical points. It's where it's undefined. There we go. And it's undefined, undefined. A of t has, so a little hard to look at the critical points here. So so A of t, we're just going to, rather than evaluate critical points, we're going to evaluate, no, wait a second. You know what? Instead of the sign chart, I don't like the sign chart so much for the table. For the graph, I take it back. I think it might be easier, rather than trying to do a sign chart, is just looking at the graph and identifying whether whether velocity is positive, velocity is negative. Now, oh, you know what? Never mind. Let's do a sign chart. But you know what? I had an error there. And you know what my error was? My error was I listed the critical points for acceleration instead of the critical points for velocity. Critical points for velocity is still when velocity is 0 or undefined, and velocity is 0 at 1, what would you call that, 4.75 maybe? So here are the critical points for velocity. Is when velocity equals 0 or undefined. I'm thinking of acceleration. So acceleration, v prime of t, which is acceleration, a of t. All right, that's undefined at 2. and 6 because of those corners on the velocity. So the derivative of a function is going to be undefined when you've got a corner on the original function. So that 2 and 6 belong on acceleration. We need 4.75, I guess I'd call that, and 7. And that's where these are 0. All right, so now all we have to do is look at our graph to figure that part out. All right, and then I have no idea where we're going to write up speeding up and slowing down, but I guess we'll figure that out. All right, so for values less than 1, right, so right here, velocity is positive, right? It's above the x-axis. So from 0 to 1, velocity is positive. From 1 to 4.75, velocity is negative. And from 4.75 to 7, velocity is positive. All right, so now we're going to have to look at either side. We have to consider on either side of 1 here. But it's not going to, so if we're looking at acceleration, acceleration is going to be the same for all the values less than 2. All right, but we'll do a sign for each one of them, right? A sign by the 1, and a sign for less than 1, and a sign for between 1 and 2, just to sort of match our sign chart here. All right, so for less than 1, all right, so the slope of the velocity curve is negative, so acceleration is negative. All right, and it's negative from 0 all the way to 2. So these are both negative. So notice, if we look at our sign chart here, we are slowing down from 0 to 1. Actually, we'll write it up here. So I'll just put a little. You know, we can put it right here, actually, because we're just going to answer this. So if velocity and acceleration have the same sign, the object is speeding up. There we go. All right, so now let's answer the speeding up, slowing down part. All right, so particle is speeding up. Oh, excuse me. So we're slowing down, first of all. We are speeding up right next to it, though. The particle is slowing down from 0 to 1. We'll put in our reasoning one time. So from 0 to 1, these two don't match. All right, so, but from 1 to 2, they do match. All right, so the particle is slowing down from 0 to 1, but speeding up from 1 to 2. Now we can only evaluate up to 2, and then we have to look at the other side. We have to look at acceleration on the opposite side of 2, on the other side of 2. But at least from 1 to 2, we're speeding up. All right, so now let's evaluate. Of course, this is going to be negative all on that interval. So everything between 1 and 4.75 is negative, and you can see that it's below the x-axis. What about from 2 to 4.75? All right, well, now velocity has a positive slope, right? So acceleration is positive. All right, so here these two don't match. I'm trying to circle, but hopefully I'm not blocking. I don't know. I'm not going to put this circle. I'm not going to try and circle, but just look up and down. All right, so notice they don't match because for values between 2 and 4.75, velocity is negative, but acceleration is positive. So this particle is slowing down from 0 to 1 and from 2 to 4.75. All right, so now let's look on the others. So this is going to still stay positive all the way through that interval, right? So we have a positive slope for velocity from 2 all the way to 6, right? So that means we match right here, right? We match from 4.75 to 6, right? Because they're both positive. Right, here, see, those are both positive. All right, so we're speeding up from 1 to 2, and then again from 4.75 to 6. So you see how I'm going between the two critical points, the critical point for velocity and the critical point for acceleration. And then you just have to be careful, right, and go between each critical point. So I had to stop at 1 and look at it. I had to go from 1 to 2 because I hit a critical point. I had to go from 2 to 4.75. I had to look from 4.75 to 6, and then from 6 to 7. So speeding up from 2 to 4.75. But there's only 2 slides. It's a lot longer video than I planned it to be. But all right, so now let's go from 6 to 7. All right, so we know this is positive, right, because it's going to be positive on that entire interval there because it's above the x-axis. How about acceleration? So acceleration from 6 to 7 is negative, right, because we have a negative slope on velocity. So the particle is slowing down from 0 to 1, from 2 to 4.75, and from 6 to 7. And the particle is speeding up from 1 to 2, and 2.2 to 4.75. And we should probably put a reason in there. I'll just separate it out. Here, B of t and A of t have different signs. That's why it's slowing down. And here, B of t and A of t have the same sign. Right? And that's all there is to analyzing acceleration and velocity using a table, using an equation, using a graph, and using a sign chart. So thanks for watching, and bye for now.